Hello everyone, I hope you are fine. Today our topic is why sky looks blue. But before that, I want to discuss some interesting facts about nature. Our world is very beautiful because of colors. We see colors are different things in different sides. For example, the color of plant leaves appears blue, the color of apple is red, and the clothes possesses different colors. But the main question is this, that why sky appears blue, or why plants looks green, and why apple is red, and why sky appears during daytime blue and during sunset or during morning it appears yellowish or in reddish color. So science answers questions like these. So let us now discuss what is science about, what is science says about these questions and how science explains these questions. Today our topic is why sky looks blue. Basically, our sky color is due to the two main reasons. One is due to the atmosphere and other one is light of the sun. These are the two main factors which play an important role in the color of the sky. Now, the light of the sun basically possesses seven primary colors, and these seven primary colors include violet, indigo, blue, green, yellow, orange, and red, which we can memorize by Artoron with Gior. So, these colors possesses a particular order. This order of color is very important on the basis of their frequency, energy, and wavelength, because we know that different colors possesses different frequency, different wavelength, and different energy. So if we see here, we arrange these colors in a particular order. This is the violet, indigo, blue, green, yellow, orange, and red. Look at this. The waveform of violet color shows us that the peaks of the waveform of the violet colors are very closer to each other. It means it possesses shorter wavelength than indigo light, and indigo color possesses shorter wavelength than blue light. And if we go towards last color, here we see that the wavelength of the red light is longer than all of the rest of the color. It means that red color possesses longer wavelength, so frequency will be smaller and hence energy will be smaller. So violet light is more energetic than indigo, indigo is more energetic than blue, and blue is more energetic than green, and green is more energetic than yellow, and similarly red color possesses longer wavelength and smaller frequency and a smaller energy. Now, why we discuss these things here? Basically, atmosphere and light play role in the scattering process. But what is scattering? We come towards that, but before that we discuss our atmosphere. Our atmosphere possesses gases, smokes, dust particles, and moisture. Our atmosphere consists of air, and air consists of different gases like nitrogen, which is 78% in atmosphere, 20% of oxygen, and the rest of the other gases like carbon dioxide and argon possesses only 1% of our atmosphere. Now, scattering occurs due to the sunlight when sunlight interacts with atmospheric particles. And what is scattering? Scattering is basically the bouncing out of the light particles or of the light from the air particles. When light of the sun bouncing up from the air particles, scattering occur. And this scattering is different at different angle. It is different during the sunset or sunrise, and it is different during the daytime. That's why, due to the different angle of scattering of the sunlight from the air particle, the color of the sky looks different at different times. So we discussed that here. But for the scattering, there is an important law which is known as Rayleigh law of scattering, and it follows Rayleigh law. Rayleigh law suggests that intensity of the scattering light is inversely proportional to the fourth power of the wavelength. It means that longer wavelength light intensity will be smaller during scattering, and shorter wavelength light intensity will be greater. It means that more energetic light will be scattered more, and less energetic light will be scattered less. But the question arises that violet light is more energetic and indigo light is more energetic than blue, then why our sky looks blue, not look violet or indigo? The main reason for this is that our eye are more sensitive to blue light. This is one of the reason. And the other reason is that if we look the spectrum of the sun, so in spectrum of the sun we see here that the probability of the blue light scattering is more than violet or other light during the daytime. So that's why our sun, when our sunlight scatter from the air particles, or sky look blue, not look violet or an other color. So this is the main reason behind the appearance of our sky as a blue color. Now the other question is that why clouds appears white? When we see clouds, they don't appear blue or other colors, they look bright. As we know that clouds consist of the moisture particle and ice particles. When sunlight strikes with that ice particles or moisture particles, it scatters in all directions. So no one color appears, because when all lights, all wavelengths, all these seven wavelengths, all these seven colors lights are scattered from a particle, then white appearance are occur. That's why we see clouds are white. Similarly, the leaves of the plants appear green, because when light strike the leaves of the plant, it only absorb the green. It absorb all types of color, and only scattered is the green light. So when only green light scattered and rest of the color are absorbed, as a result of that, the leaves of the plant appear green. And apple appear red. Why it appear red? Because it only scattered red light and it absorbs rest of the light. That's why apple appears red. So in this universe, we see the colors of different things are different. So the main reason behind that is basically the phenomena of occurring of scattering. So when light scatters from a particle, it looks in a particular color. So that's why we see here in our universe different colors. So I hope you got a basic idea about why sky looks blue. And the one other important thing is why sky look during the sunset or morning time yellowish or reddish. So for that, the main reason is that during the daytime the sun is on top, and there is a the sun is on shorter distance from our eye. So that's why the scattering of less particle occur compared to the sunset or morning. During the sunset or during the morning, there is more atmosphere between our eyes and sun. So more atmospheric particle means more interaction of sunlight with more particles. So when scattering is large or more interacted particles are there, then the reddish color probability or yellowish color probability is greater in that times. And when during the rest of the daytime, as we know that less particles are involved during the scattering, So sky appears blue in all of their rest times. So I hope you got the idea about the scattering, and inshallah we appear next time with another interesting video. Keep in touch. Thanks.